This video is brought to you by Sporlan, quality, integrity, and tradition.
We got a call on some Cook's drawers not working. We went downstairs, the thermostat is calling. It's like 70 degrees in the box. This is the compressor right here. So we're putting our service gauges on it to figure out what's going on. The compressor is not running at the moment. All right, we've got the compressor opened up. The compressor is really warm. We're gonna go ahead and check voltage. Let's see, this wire and this wire. And we have 202 volts. This is a 208 single phase, so that is power. It should be turning on right now, but it's not. It's really, really hot, and I think it's turning on and off on overload. It's kind of loud, but I think I can hear the overload clicking. So what we're gonna do is go right here and right here. And yeah, I'm not making a good connection, but we have 202 volts across the thermal overload, which means that the switch is open. The thermal overload is stopping this compressor from trying to start anymore. So there's something wrong here. Now, compressor, like I said, is extremely hot. So before we go any further, let's go investigate the condenser and see if the condenser is plugged up, because if it is, it could be causing it to go up on thermal overload. It's certainly not the cleanest thing, but it's also not the dirtiest thing. So, I mean, it doesn't look horrible. We're gonna come in here, and this is system D as in David. We're gonna go ahead and turn it off, right there. And then we're gonna check out the starting components on this guy. So the starting components are in a crappy location back behind it. So we'll have to get the whole housing disconnected, and I think we can bring it around and investigate. Can't really read the microfarad ratings, it's kind of difficult. You can kind of make it out a little bit, but this capacitor is so hot, like I can't even hold it. But the microfarad is 88 to 106. So it's reading 112, which is interesting because that's rather high. But we're gonna put it back in and then check the run cap. So the run cap is a 15 microfarad. Let's go ahead and test that guy real quick. It's pretty darn close to being good. I mean, it's a hair low, but interesting. Well, let's cool this compressor off. We'll go get our tool and we'll cool it off. We'll get some bags of ice or something. We'll figure it out. And we'll cool it off and see if we can get that thermal overload to reset. All right, I've got the cool presser tool on there, cooling off the compressor. Now, this rack has got massive water leaks. It leaks down into the building, so I try to avoid washing it, but I had to. I had the hose up here, so I just rinsed it real quick. We didn't put any cleaner on it. We just gave it a quick rinse, and we'll see what that does for us. I don't even know. We may still have a bad compressor. It's hard to say because the rack wasn't that dirty, so, but we'll see. But they're just gonna have to deal with the leaks for now. Normally, like if we're gonna clean this rack, we bring a shop vac with us, a big one, and we have, you know, 2 guys running 2 different shop vacs, sucking all the water out as fast as it's falling down. But that's not happening today because it's really hot. So it's probably about 100, 105, something like that outside. So let's see what happens. It's not running. I don't think it's gonna reset. No, I think I can hear the overload clicking on and off still. Yeah, it just tripped the overload again. We'll try to cool it for a little bit longer, but the overload was reset, but the compressor is just not starting. Okay, we're getting power, and it's trying, but then it clicks off on overload. So it's a last ditch effort. I pulled the overload out just to see if I can get it to start. We're gonna measure the current and see what happens. Here we go. 33. Lock rotor amp is 37. So we're pretty much drawing lock rotor. It's not doing anything. Go ahead and kill it. Trip the breaker. Did it trip the breaker? Yeah, it tripped the breaker. This guy's done. This is an original compressor from 2004. We've changed just about every other compressor in here. These things just, you know, they're run to the ground. It's just so dang hot. So it doesn't surprise me. So I'm gonna get all the information down. We're gonna talk to the customer. I'll probably end up having to change this tomorrow. This is Friday, July 9th right now. So we'll see. I might have to see if I can locate one. I'll see what I can do tonight, but that's it for today. I'm gonna go give the customer the bad news. All right, you know, I try to be as efficient as possible. It's still frustrating though. So we gotta go through that access, through this scuttle, and then to this one. This hook is a lifesaver because I'm able to thread this down, and if you carefully place your products, you can hook them, you know, and pull it up. Now, because it's so confined right there, you know, I'm gonna have to go down and kind of move some stuff, but one of these hooks, man, is really a lifesaver. This is made by Klein, the electrical tool manufacturer. I just pick it up at my local supply house, but these things are awesome, man. They're a lifesaver. I'm already tired, and it's only 8:42. I damn near brought my whole van up on the roof, and I'm still gonna have to get more as time goes on, refrigerant and stuff more than likely. We're going to get everything staged where it needs to be. I've got a rope kind of staged right here, and I am a nut, guys. I do this. My rope is down here. I leave it there so that way when I go down I can pull stuff up, and I don't like my rope sitting on the ground in case water comes over here and stuff. So I'm all crazy about making everything nice and tidy as possible, you know. So we're gonna get everything over here. Where first step we got to do is start recovering the refrigerant from the compressor. It's 85 and climbing. It'll probably hit 105 today, so it's only 8:40, so in a couple hours we'll hit 100. It's gonna be a long day. I had a brand new recovery cylinder, so it needed to be evacuated. So we've got that running while I'm gonna start getting the rack opened up and getting all my stuff out here. I'm gonna get a water hose laid out with a mister because like I said, it's gonna get hot today. So plan is to reuse the existing refrigerant that's in the system. So to do that, we gotta make sure that we have a properly evacuated cylinder. So we're down to 338. Now it's natural that it is gonna rise, but it's okay. All right, so we're gonna go ahead and get this guy set up and hooked up and get the refrigerant being pulled out of the system so we can get in there. Now this compressor, of course, because it's an older compressor, that's the compressor that's bad. That's the compressor that's replacing it. So it's gonna be a partial repipe, because stuff is in different places, which does suck, but it is what it is. So I purge everything, open it up, leave everything open, and leave this loose. So that way we purge all the air out of the lines, and then we're ready to open this guy up, and then turn this guy on. Now, it's only 85 degrees right now. If I was having a problem, we could put that in ice, and I did bring buckets up here, but because we've got some cloud cover in the sky and it's kind of cool at the moment, I don't think we're gonna need to do that. I did use large diameter hoses from here to here, okay? So those are 3/8 ID. So that helps to speed up the process and reduce the restrictions. The biggest issue is the outlet, because this is your discharge. And when you see this start going, I think this thing cuts off at 450 or 500 or something like that. That's when it becomes a problem, but I think we're gonna be okay. The recovery's just about done. I'm just unbolting, unscrewing. There's a very good possibility I'm gonna change the dual pressure control if I have one in my truck. Recovery, yeah, it's just purging right now. I have it on the self-purge. So yeah, we're doing good so far. When it's a repipe like this, everything's a little bit different. So like I had to move the discharge valve. I had to twist it out of the way because the rotor lock for this is gonna come out to here and it's gonna butt heads. The new discharge line is gonna be all the way back around here. So we're gonna have to come up. I don't like doing that, but it is what it is. This will be a process port for suction line. We'll put a stub there. I've got it bolted down. We'll deal with the electrical and the start component box when we're all done, because this is a single phase. So this right here is going to go straight down into that valve. I'll go get some 5/8. So baby steps. We'll change the dryer last. I'm trying to think about the next guy when I'm piping this thing in, okay? So what I'm doing is I'm putting the pressure control on this side of this valve, and I'm putting the pressure control here instead of on the rotor lock valve, so that way we don't have to fight the rotor lock valve. We'll have access ports because I'll put service tees on there, but if we ever need to change the high pressure control, we won't have to recover the entire charge. we'll just close that valve down. So before, they had it on the wrong side of the valve and it was a pain. Next, we're gonna go ahead and, I've already pre-piped this and swaged it, so we're gonna sweat in this one right here, but we're gonna have to use silver solder because it's steel to copper. So I'm using 56% silver solder. We're using Stay-Sil Paste Flux. We're gonna sweat that on, then we'll put some nitrogen on the system and sweat everything else in. All right, I got the nitrogen hooked up on the other side. We're gonna get in here and braze this stuff in real quick. All right, it's all sweat in. I got to put the Rotolock gasket in still. Another thing I didn't point out, whenever you're brazing on these Rotolock valves or these steel valves, you need to actuate the stem, okay? Mid-seat it. You never want it one way or the other. You want it in the middle because they will get stuck, trust me. So I'm gonna inspect my welds or braze joints one more time. We gotta change the Liquidline filter dryer, which is a flare. That shouldn't be a problem. And then we'll do a pressure test and pull a vacuum. Now, pretty confident this system has leaks because I've been chasing a very small leak in this guy for a while, so we're probably not gonna get a perfect vacuum. I'm using a service tee on this guy and it has a Schrader depressor in it, so I put a Schrader in this guy. So that means that I'll be able to change this, this high side pressure control without losing the charge. I just bust this guy off, okay? So that way it makes it easier. Again, I still have a valve there too, but I can now change a pressure control without even having to close that valve. All right, so we're gonna undo the dryer, you clean the flare fittings off real good. I got a wet towel. We're gonna put a new Sporlan catch-all and see-all, so sight glass and dryer. And as usual, I love the flare combination because if you ever repair leaks and you have to come up onto the roof, you don't have to bring your torches up to change the dryer, just a couple fittings, you know? So we're gonna slap this guy in real quick, and then we'll do a pressure test and an evacuation. All right, we got it all wired in. So we have our starting components tucked back there, dual pressure control, and main power coming in. Broke the dual pressure control with one of the lines, the 208 single phase. And then, yeah, we're gonna put the cover back on and then pressure test. Well, we're just about there. Running a pressure test at the moment. Using the tightness test on the field piece manifold. Like I said, this thing, it's changed about 1.1 PSI. I think it has leaks, but we're gonna give it some more time. I've got a mister running right now because it's, well, a minute ago it was 105, but it's dropping the temperature just because I'm running this to try to cool myself off, although my bag's getting a little wet, but we're getting there. Started the vacuum pump. We've got I want to point out that I have a micron gauge here for a reason. This is not where you normally put a micron gauge. The only reason to put a micron gauge on your pump is to test the pump. But I'm going to show something in a little while once we start the evacuation. So I started the field piece pump up with the gas ballast open, okay? We're going to do our initial pull down, and then we'll close the gas ballast and start the actual vacuum. So I just kind of wanted to point out that there's going to be a difference between the two because this is further from that vacuum pump. So 1400 microns, and this one's at 800 microns. So I'm just trying to point out that placement of your micron gauge is very, very important. Now, I'm pulling from both sides of the system right now. Eventually, I'll probably shut off one of the ports and then just do a true vacuum to where the actual vacuum micron gauge over there is the last point in the system, but we'll get to that in a little while. That mister's really helping a lot. Okay, it's not the prettiest thing in the world, but I went around with some silicone and sealed up the things that I didn't want to vibrate, okay? It kind of looks like a turd, but it'll stop things from rubbing out. You know, the conduits, this guy rubbing on there, that conduit, it'll help, okay? It's not the prettiest, like I said, but it's functional. So I've already closed off the high side port on the receiver as far as the evacuation goes, so we're only pulling through the low side now. So it's gonna slowly start rising because of that, but eventually it'll stabilize out and start lowering again. It's just that it was getting such a high pull from the high side. So we'll give it a few minutes longer and see where that gets us. So it's really important that when you're all done with your evacuation and you choose to hook up your gauges, that your gauges either be purged or pulled into a vacuum. So I have not opened the valves, and I'm just pulling evacuation on my gauges. That way they're good, and then I'll open it to the system and go from there. All right, we're purged all the way up to here. Scale zeroed out. We're gonna open it up on the high side. Dump refrigerant into there and go from there. So we're gonna dump all this gas into there, and then we'll check the liquid level and go and see if we have to add more. All right, it won't take any more gas. It took 7 pounds. We'll have to meter the rest in through the low side. What I did, because this unit's like 80 degrees down in the box, so it's got 4 coils, it's really gonna flood back to the compressor. So I throttled down the suction service valve really low. Got a compressor on there. We're allowed to run 9.1 amps. So we're gonna kind of monitor it because we don't want to overload the compressor. So we're gonna fire this guy up and hope that all is well. That I did everything right. There we go. 9.2 amps, so it's running. We have refrigerant, so we're just gonna meter in the refrigerant with the suction service valve closed like that because we're trying to act like a compressor CPR valve, like a crankcase pressure regulator. We're slowly throttling the refrigerant coming back to the compressor. At the same time, you don't want it to run too long like that because you could overheat the compressor too. This misting device is actually helping too because it's cooling it off. It's over 100 outside right now, but it's reading 96 in here. So we're doing good so far, but you can see we have a really high suction pressure. Even with that valve throttled back, the compressor's frosting up. So we're just gonna let it run for a bit, slowly adding a little more gas. All right, it's warming up now that I turned the mister off. It's about 103. I imagine it'll get up to 105. This guy's done, it's installed. We're still flooding back pretty good though. But, you know, not much I can do about that. It's got the right amount of refrigerant, liquid level's good. We still need to get a crankcase heater because that one doesn't fit. So we need to do that. We'll come back on another day. This is all put back together. Everything's good. Liquid levels marked. We're gonna call this one done. Hopefully get home. I don't know. I think I gotta go run another call though, so we'll see. But hopefully I get home at a decent time today. I'd like to enjoy my Saturday a little bit.
It has been a long weekend, to say the least. So today is July 10th. So July 9th was a long day. I worked until midnight. After the first part of this video, I went home and I sat down and I started to watch a movie with the family. And then I got another service call, so I was gone for like another 4 hours doing a walk-in freezer repair. And then I got home about midnight. I slept for, I think, 6 hours or so, and then woke up and went and did this compressor job. And then I got done with this compressor job around 11 a.m. and then had 2 more calls after that, a walk-in freezer call and then a walk-in cooler call. And then I got home maybe, let's see, it's 8:50 p.m. now. I got home maybe about 6 o'clock in the evening, and then I've been editing for the last 2 hours. So it's been a long day. I'm sure I'm going to get calls tomorrow too. Tomorrow's actually my daughter's birthday, so I'm hoping I'm home for most of that. But anyway, so you know, it's important to have proper hydration, right? It's well over 100, 105, 110 degrees this last week. It's been really hot, and we've been just, you know, nonstop busy. Boom, 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 you know. Anywhere from 8 to 12 hours every day, just knocking it out. So it's important to remember to hydrate and to eat food. See, I'm the worst person at eating food, but I do remember when it starts to get hot, it's like I have to force myself to eat. Because for me, I don't know if it works the same for everybody else, but what happens is, you know, I don't eat breakfast. I know that's horrible, but I don't. I don't eat breakfast. I drink coffee, have water and all that stuff, and then I usually eat a decent lunch and then dinner. But I start to crash big time. And I'll get jelly brain from the heat, you know, and I could drink water all day long, but still, I need nutrients, you know, your body needs things calories to burn, so that way it can function. At least mine does, okay? So I have to force myself to eat, but I really make an effort. And actually having an apprentice with me really helps, because I'm forced, like, you know, we got to take a lunch at the right time, you know, and all that stuff. So it really helps me to keep food in my body and have energy to make it through these days, okay? So, you know, we have to work these long hours sometimes. So when it comes to, you know, having the proper energy and staying hydrated, it helps you to have a level head when you're diagnosing things. So this one was a little confusing, a little frustrating. I will say that I didn't catch it on video, but I ended up, because I was a little bit worried about that capacitor. It was kind of a funky reading. So what I ended up doing was going and grabbing a universal start cap, because I have those ones from Amrad. If you guys didn't know this, Turbo 200, you know, they make those universal run caps. They actually make a Turbolytic 50, which is a universal start capacitor. So I actually took one of those and threw it on the system, because I was a little bit worried about that capacitor reading high, the start capacitor for this one, and it still wouldn't start. Okay, so you know, compressor was dead for sure, and it happens. You know, it's an 04 compressor. It's lived its life, you know, and it's constant abuse from this customer, running in this high ambient temperatures and stuff like that. So dirty condenser all the time. I mean, it's just inevitable. I did save the compressor because I want to autopsy it. I'm very curious, you know. I don't always get to do that, but it is kind of nice in weird situations like this, because I want to know what killed it. Like, what made that compressor lock up? Is it out of oil? Because if it is out of oil, that oil is down in the system somewhere, and it's probably going to make its way back up to this new compressor. So I will autopsy it in the future. Unfortunately, I didn't have time to do it before this video. I probably won't get to it for a week or two, just with how busy we are. But you know, other than that, I had an apprentice with me the first part of the video, but then when I came back, it was Saturday, I was by myself, you know, so you try to work as efficient as possible, try to stage everything, lift it up with the rope, you know, and same thing, I was running the misting device the whole time I was working, keeping me cool, and every time I went down to the van, I took something with me. I had to force myself, like, hey, because sometimes I'm like, no, I'll do it all at the end, but no. I had to force myself, because I didn't want to spend 2 hours at the end roping stuff down, you know? So every time I went down, I took something with me. I brought something up, back and forth, back and forth. And I try, for me, to make sure that I set everything up so that way that makes that easier. Like leaving the rope hanging down, because oftentimes I'll go down and not be thinking about it, and boom, 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 come back up, and it's like, oh, then you got to climb up, get the rope, drop it back down. It's just wasting energy. So try to keep the rope hanging down so that way, you know, when you do come back up, you can just rope it up. It's super easy that way. Again, trying to stay cool. So I repiped the system in a way that it's going to make it easier for us in the future. Pressure control failures happen. And on these systems, the way that they're designed, when you have a high pressure control failure, it kind of sucks because you got to recover the entire charge to change the high pressure control. Well, the way that I set this one up with Schraders behind the swivel tees or the access tees, now you can just loosen the access tee. It'll, you know, stop pushing on the Schrader, and then boom, you can change the pressure control. So try to think smart when you're doing repipes and installations. I don't like to try to reinvent the wheel, but in a situation like this, you know, it was easy. You know, it wasn't a big deal. I had to repipe it anyway. So got the system started back up. The evacuation actually went a lot better than I thought, and the pressure test went a lot better than I thought. I still think that I have a small leak in the system, but I mean, it was doing really good. It passed the evacuation and it passed the pressure test, surprisingly. So we'll have to see. You know, it's possible that that leak that I've been chasing was in the compressor. I was thinking about that. Maybe it was in the service valve or something and I just couldn't see it. I don't know. But the system is up and running. I was a little bit frustrated because the customer had come up a few times while I was working and they were kind of like, "Are you done yet? Are you done yet?" And I just told him, "Dude, I'm not going to be done for a couple hours, you know?" And you know, he was cool. Like, he was very apologetic. Like, "I'm so sorry you have to work in the heat," that kind of stuff. But so when I was all done, I went to go take my stuff down and he's like, "Cool, so we can put stuff in the box now?" And I was like, "Yeah, you guys can load it up. It should be down to temp." Then I go over to the box to look at it and it's like, dude, they already had food in there. Like, what are you guys thinking? Whatever. You know, it's not my problem. So I just told him it's going to take that much longer to come down to temp because I don't know when they put that food in there. So now I'm trying to bring down, you know, the temperature of the food and whatever. But it was a long day to say the least, okay? Lots of service calls and lots of cleaning, essentially, okay? You know, when it comes, I wanted to talk about the water leaks too. I kind of talked about that a little bit in the first part of the video. This customer, so the way that they installed that refrigeration rack, they did not leave anywhere underneath the rack for water to drain out. So naturally there's holes underneath the compressors. There's little screw holes and different things like that. It's not 100% waterproof, and water gets underneath the rack and then it gets onto the flashing that's underneath it, and the flashing must have holes in it and be rotted out. So it leaks down into the building. And so the first day that I was there, the customer came up and they're like, "What the heck, it's leaking water everywhere. Make it stop." And I was like, "Nothing you could do, man. Like, deal with it." You know, I wasn't trying to be a punk, but I usually try to be very careful washing that rack, but it was so hot and it was just like, guys, I had to wash it, you know? So you're just going to have to deal with the water leaks. I've told them so many times to get a roofer out. Unfortunately, I hope they don't get a roofer out anytime soon because we have to lift that rack up. The solution is we have to lift the rack up enough for a roofer to get a whole new flashing underneath it. And then we need to put it on like 1x2s or something like that. So that way it has drainage now. So that's going to be a whole process. And you know, roofer has tried to get in there before and he masticed the heck out of the line set penetrations and stuff. So it's just going to be a miserable mess trying to lift that rack up. I don't want to have to undo every refrigeration line. So the theory is we'll have to get the mastic out from on the refrigeration lines. And then we have a good 12 inches where there's a riser for the refrigeration lines before they go over to all the units. So if they do it right, if we have a crane correct, we can lift it up, you know, and put blocks underneath it or whatever, and then slowly set it down, you know. Or I've done it before, like we could put a bunch of airbags under it or all kinds of different things. So that'll be a whole nother process for another day, you know. Anyways, I really, really appreciate you guys making it to the end of the video. If you guys haven't already, please check out my website, hvacrvideos.com. It's a cool way to support the channel. We got some shirts, some hats, all that good stuff on there if you guys want to support it. But you don't have to support it just by buying stuff. The easiest way to support the channel is just watch the videos from beginning to end without skipping through anything. That's the easiest way, guys. Other ways, if you want to support too, you can support via Patreon. You can become a contributor to the channel. It's like a monthly subscription. You can choose the amounts. You can support it via YouTube channel memberships, which is very similar to Patreon. You can support it via PayPal. There's links in the show notes of this video, or obviously hvacrvideos.com, and then we have merchandise available. You know, all of that stuff just helps to kind of supplement a little bit for all the time and craziness that I put into these and all that good stuff. But anyways, I really, really appreciate you guys, and we will catch you on the next one, okay?